This problem requires us to graph the conic in polar form. So what we need to do first is to identify what conic is this. To do that, we must rewrite this in standard form. And what is the standard form? This number right here should be 1. So what I'm going to do is multiply this by 1 in the form of 1/3 over 1/3. So the resulting polar form is -2 over 1. 7 times 1/3 is 7/3 sine theta. Because this is 7/3, that's your eccentricity, then we know that it is a hyperbola. Okay, so now we can just graph this using 4 values of theta. So let's put our values here. R theta, and we will use 0, pi over 2, pi, and 3 pi over 2. Here's our pole, and here's our polar axis. Here is the line theta equals pi over 2. Because this is a sine curve, then it is symmetric with respect to the line theta equals pi over 2. Here we go. At 0, sine 0 is 0. 0 times 7 is 0. 0 plus 3 is 3. -6 divided by 3 is -2. So when the angle is 0, the value of r is in the extension -2 right here. At pi over 2, sine pi over 2 is 1. 1 times 7 is 7. 7 plus 3 is 10. -6 over 10, or -3/5. So at pi over 2, the value of r is in the extension. If this is -1, then this is -1. -3/5 should be somewhere here. At pi, sine pi is 0. 0 times 7 is 0. 0 plus 2 is 3. -6 over 2 is -2. So when the value of the angle is pi, the r is at -2. It's at the extension. So 1, 2. Finally, at 3 pi over 2, sine 3 pi over 2 is -1. -1 times 7 is -7. -7 plus 3 is -4. -6 over -4 is +3/2. So at 3 pi over 2, which is this angle right here, so the value of r is 3/2, that's 1 1/2. If this is 1, this is 2, so this is our point right there. So the hyperbola goes like this. And we'll just copy that on this side. Now, the directrix is determined by the value of d. Okay? We recall that the numerator is given by dE, right? So dE is -2, and we know that the eccentricity is 7/3. So solving for d, that should give us -6/7. So the directrix is -6/7. That's almost at -1. So here is the directrix. Right there. Y is equal to -6/7.